before we start, we got to know what an independent event is and a dependent event is. Let's talk about what an independent event is. So an independent event, so what do I mean by this? So let's say if we have these two events right over here. This first event is going to be me flipping a coin. All right, so it's heads or tails. And then the second event is me have this like spinner, right? And I spin this spinner around and I get some sort of color. It's going to land on some sort of color. Now, two events are independent when one event does not have an effect on the probability of another event. So let's say if I flip this coin and I get some sort of result, that does not affect the probability of me getting, let's say, yellow when I spin this spinner, right? So these two events basically have no effect. They have no effect on the probabilities of each other, which means that, they're independent events. However, let's say that, let's say if we have a bag of marbles. Okay, so dependent event, you can probably guess what that is. That's just the opposite of an independent event. So it's when kind of two events, have an effect on each other's probability. So let's say that my first event, so I have this glass container, right? And it has 4 blue marbles and 4 yellow marbles. And let's say my first event, so this is event 1. For my first event, what I'm going to do is I'm going to be blindfolded. I'm just going to take a random marble out without replacement. So without replacement just means that, let's say if I pick a blue marble out of this container, well, I'm just going to leave the blue marble outside. It's not going to be in the container no more. All right. Now, does this affect my chances of picking a blue marble on my next turn? And the answer is, well, yes. Dependent events, one event has an effect on another event. In this case, event 2 is picking a blue marble on my next turn. So let me show you an example. So let's say that for my first event, I randomly picked out a blue marble, okay? So I randomly pick out a blue marble, and remember that this is without replacement, meaning that the marble is just going to be gone after I pick it out, okay? Now, does this affect the chances of me picking a blue marble on my next turn? Well, yes, because now notice how we have 3 out of 7. So notice how if I pick a blue marble out of this container, well, now the chances of me picking a blue marble on my next turn is 3 over 7. Right, originally, look at the container. We had 4 blue marbles and 4 yellow marbles. So the chances of me picking a blue marble out of this container is 1/2, or 50%. But after I pick out a blue marble from this container, well, the chances have changed, and it gets affected, right? Now the chances are 3 over 7. So you would kind of say that, these two events are dependent of each other, right? The probability of one event depends on, what happens in event 1, right? So yeah, that's independent and dependent event. Now, you can check if two events are independent or dependent of each other based on, you have 2 ways of doing it. So the first way is the probability of A. All right, the first way to do this is you can just multiply the probability of these 2 events occurring, and you can compare it to the probability of A and B occurring. And, if it's true, then it's independent, and if it's not true, then it's dependent. And don't worry, I'll give you examples so you can kind of understand it, but I'll just kind of explain the formulas here. So the second formula, you have if the probability of some event is equal to the probability of that event, given that the other event has occurred, well, then it's going to be independent. But if it's not true, then it's dependent, okay? So kind of the key thing to remember for these formulas is that if these equations remain true, the 2 events are independent of each other. If these equations do not remain true, then, these 2 events are, dependent of each other. So let me give you an example of what I mean. So let's say if I have a fair 6-sided die, and let A be rolling an even number, and B be rolling a number greater than 4. Are A and B independent of each other? Well, what's the probability? So I have a 6-sided die. All right, so if I have a 6-sided die, I have kind of 6 outcomes, right? I could either land on 1, I can land on 2, 3, 4, 5, and 6. All right. And what's the probability of, let me just write this down. All right. Okay. So what is the probability of A and B? And in this context, what is the probability that I roll an even number and that number is greater than 4? So what's the chances that if I roll a die, I roll an even number and that number is greater than 4? Well, an even number that's greater than 4 is 6, right? There's only kind of one option for this. So the probability of me rolling an even number and that number being greater than 4 is going to be 1 over 6, right? Because there's 6 possible outcomes, and the only number that's greater than 4 and is an even number is 6, right? So there's one possibility out of 6 total options. Now, what's the probability of A times the probability of B? So what's the probability of rolling an even number? Well, the probability of rolling an even number, you can kind of see that it's just going to be 1/2, right? Because, there's 6 options in total, and half those options are even numbers, so yeah, it's going to be 1/2. Now, what's the probability of me rolling a number greater than 4? Well, out of 6 possible options, only 2 numbers are greater than 4, 5 and 6, right? So it's going to be 2 out of 6 for my probability of B. Now, if I multiply these two things together, I'm going to get 1 over 6. And notice how the probability of A and B is equal to the probability of A times the probability of B, meaning that these two events are independent. Okay, so, right, if the probability of A times the probability of B is equal to the probability of A and B, then two events are independent. And you've probably seen this before, right? For example, going back to my coin and the spinner example, let's say that the chances of me landing on yellow is 1/3. And let's say the chances of me landing on heads is 1/2. So what's the probability of me landing on heads and landing on yellow? So landing heads on the coin and then landing yellow on the spinner. And you would probably say that's easy. Well, it's just going to be these two probabilities multiplied by each other. So it's a 1 over 6 chance, right? That for my coin flip, I get heads, and then for my spinner thing, I land on yellow. Right, and that's exactly what this formula is, right? If two events are independent of each other, like these two events, just multiply out the probabilities and, it's going to remain true. But if it's dependent, then this will not be true. But what is the second method? What does this mean? The second method is the probability of A is equal to the probability of A given B. So this dash right over here just means given. So we're kind of given that B already occurred in the first place. All right, and if these two probabilities are equal to each other, well, it's going to be independent. But if it's not, then it's dependent. Let me show you an example. We're going to go back to the coin flip and the spinner example. Let's say if I highlight, let's say if getting heads is symbolized as the probability of A, and let's say getting yellow on this spinner is represented by the probability of B. Now, the probability of A, what's the probability of A? The probability of me getting heads is 1/2, right? Now, here's the tricky part. The probability of A given B. All right. Given just means that it already happened. All right. It already happened. Okay. So in this case, the probability of A given B, what does that mean? Well, that just means what is the probability of me getting heads given that we got yellow on the spinner? So if I already got yellow on this spinner, right? Then what are the chances that I get heads? And the probability for that is just going to be 1/2. Because think about it. These two events don't have an effect on the probabilities of each other. So if I get yellow on the spinner, that doesn't affect the probability of me getting heads, right? These two events, if I'm given that one event occurred, that still does not affect the probability of the other event. So therefore, these two probabilities are equal to each other because they're independent events. One event given, one event occurred, that does not have an effect on the probabilities of another event. Therefore, this formula remains true, right? And we can also use the second formula here to confirm this for our sort of 6-sided die question, right? So, let's say if probability of A, we know that the probability of A is going to be 1/2, right? We already established that because rolling an even number, we already said that's 1/2, right? Now, what's the probability of A given B? So let's say if I had a dice and I already rolled a number that's greater than 4, what are the chances that I rolled an even number on the next turn? Well, that's also going to be 1/2. Think about it, right? if I have a dice, if I have some sort of dice, and the first time I rolled the dice, I got a number that's greater than 4, okay? Does that affect the probability of me getting an even number on the next turn? No, right? They still have a 1/2 chance. I still have a 50% chance that I get an even number on my next roll, right? So these two kind of events, they don't have an effect on the probabilities of each other, right? If I'm given that, I rolled a dice and I got a number that's greater than 4, that's still not going to affect the probability of me rolling an even number, right? So these two formulas, notice how they both work. So if you're unsure, if you're, given a question about this and you're unsure of, did I do the question right? Well, you can put both these formulas to test, if the question has enough information, and, that's going to help you.